Dear friends, in continuation of the previous video lecture of for polypropylene fiber part 1, the gas phase polymerization process. In this process, the dried and purified liquid propylene gas is continuously fed to the bottom of the polymerizer reactor, while the high efficiency Ziegler-Natta catalyst fine particles introduced from top. Somewhere at middle in the polymerizing vessel, catalyst particles are catalyst particles and the upflowing propyl gas comes in contact with the polymerizing vessel, and the polymerization start. And the polypropylene particles start to go on the fine particles of the catalyst system, and the polymerization condition is kept during this gas phase polymerization in the polymerizer reactor 90 degrees centigrade and 30 to 35 atm pressure. About during this polymerization, out of total propylene gas, 15% get converted, or you can say the 15% polymer yield is results during the polymerization, while the rest of 85% go for the recycled untreated propylene gas, and finally the polypropylene is powder is continuously removed from the reactor. You can see also the diagram here. The in the first, you can see the crude propylene gas at the distillation is the purification, separation of the propane gas from propylene, and you can say it is dry, passing through a dryer. So propylene gas is purified and dried before go to the polymerizer, where it is treated at 90 degrees centigrade and 30 to 25 atm pressure. Propylene gas insert or fed continuously from bottom, and while the fine particles of catalyst is introduced from top side. Here finally the polymer intermediate storage, where the continuously from polymerizer the powdered polypropylene is removed and converted mass can be stored, and while the unconverted propylene gases go for recycles, again passing to the distillation and drying process. Next, after this, the stabilization against degradation. Yes, polypropylene fiber is highly susceptible to the thermal, or you can say the heat treatment and during heating, and as well as the auto-oxidative degradation. Yes, in presence of oxygen, polypropylene is comparatively unstable, you can say, and while in absence of oxygen, polypropylene fiber is comparatively stable. It is worth noting that the processing of the polypropylene is in the normal commercial condition or operating conditions, just like the polyester nylon processing operating conditions. But here, these conditions are not directly suitable, you can say, without adding the antioxidants to the polypropylene. By addition of the antioxidants or stabilizers, that improves the melt extrusion stability as well as long-term thermal stability and the UV light stability. Now, how the degradation reactions takes place, that is the thermo-oxidative degradation. You can see here the oxidative thermal degradation is a chain reaction. Yes, it starts at somewhere at middle or at the end, at any place where it by the application of heat it triggered and convert in a free radicals. You can see here the reaction initiation may be polypropylene molecule just heated, and it is split by just one of the hydrogen atom get separated, and pp dot plus h dot, both are free radicals and highly reactive in nature. And also in presence of, this is just thermal degradation, thermal degradation reaction, and here another, this is pph. In presence of the oxygen, it may convert into the pp dot plus hoo dot. Here they just initiate the reaction, and how it propagates further. You can see here the highly reactive nature PP dot is may react with the oxygen and convert in PPOO dot. PPOO dot further can react is the another PP, and another nucleation may results, that is PPOOH plus one molecule having peroxide in the main chain as a side group, and another PP free radical may starts. So such type of reaction, and one of the reaction may, you can see here, the H2O may results, which further hydrolytic degradation may results. Means here the oxygen and hydrogen atom convert in a water molecule, which further autolytic and hydrolytic degradation may result, which is much faster, and the termination of the reaction may results here PP dot and PP dot, the two different radicals from different molecules may combine together, and termination of the reaction takes place with the big molecules. Means here you can see the size of the polypropylene molecule after degradation is unpredictable. So that's why during the processing of such size of polypropylene materials is difficult, because of during the melt extrusion and during the melt processing the viscosity may affect. So this is overall the thermal oxidative thermo-oxidative degradation. And in the last here you can see the photo-oxidative degradation, that is PPOOH in presence of photons and ultraviolet rays. It may split into the PPO dot plus O dot H, which again the free radicals and highly reactive in nature. To avoid the such thermo-oxidative degradation, thermal degradation and photo-oxidative degradation and effect of the UV rays for degradations, some stabilizers you can add here. The stabilizers are generally classified as heat or light stabilizer. Means so different purpose, different type of stabilizer are added at the time of melting, remelting or extrusion, and these are categorized or classified as free radical scavenger. One of the example is hindered phenols can be used for this purpose, and peroxide decomposers, that is one of the dilauryl thio dipropionate, and UV absorbers, that is carbon black and Cysorb UV5S, energy quenchers, that is nickel chelates, and another type of chelating agents is also used for the metal deactivators, and HCl hydrochloride scavengers. Means from any material which is rich with the HCl, which is liberated by decomposition, and that liberation of HCl molecule may deactivate the catalyst residues if still present in the polymer system, or you can say in the polymer mass, molten mass. So to deactivate the catalyst residue, the HCl scavengers can be added. Now fiber production. PP is available in the form of chips and threaded edge. Yes, before go to the spinning or melt spinning, how it is traded in the market, you can see on the basis of their molecular weight averages and their polydisperse value. Yes, so to examine the or you can say it can be characterized by the melt flow index. Yes, the melt flow index for the fiber grade PP is measured as the weight in the grams of the melt flowing out in 10 minutes in a melt flowing indexer of specified dimensions under a 2.16 kilogram pressure and 230 degrees centigrade. Yes, through a melt flow indexer one can check the MFI value, and for textile application, textile grade polypropylene polymer, the MFI value is 15 to 25 gram per 10 minute, while the industrial application polymer grade is 3 to 5 gram flow through that specified dimension tube in 10 minutes. And here the preferable polydisperse value is 3, and now the 2 to 15 polydisperse value is available in the. Now the fiber production techniques, melt spinning is carried out mainly, and yes, here to some points need to be discussed, because the difference in the polymer quality from the rest of the nylons and polyesters. And you can see here the melt spinning is carried out 230 to 290 degrees centigrade, because it is much higher than its melting point 165. Here you can see here, if we comparing with the polyester, 260 degrees centigrade is the melting temperature, 50 to 60 for polyester and nylons, and spinning is carried out about 280 to 290 degrees centigrade, which is 20 to 30 degrees centigrade higher than their melting temperature. But here 60 to 100 degree centigrade is higher melting temperature is used for the spinning purpose. The reason being it's a high molecular weight, and this high molecular weight increases its viscosity. To normalize the viscosity, to reduce the viscosity, high melting temperature is kept for the spinning. And again, it's due to high viscosity and high molecular weight and high polydisperse value, the larger length, larger diameter, longer length, and swallow grooves type of extruders. Sometimes twin extruders are used for the better homogeneity. And because of high specific heat and low thermal conductivity of the PP, quenching path is kept comparatively longer and larger than the rest of the polyester and nylon, because PP is difficult to dye, and also because of its high specific heat. Yes, one more thing, PP is difficult to dye, therefore pigmentation is carried out by the use of the master color batches and at the time of melting and extrusion. Yes, the different type of spinning method is short air quenching method. In this particular method, entire melt spinning setup is located in one floor only, not very high that floor, and quenching zone is just 1 meter long. So therefore, because of high specific heat and low thermal conductivity reduces spinning speed. The low spinning speed, or you can say limited spinning speed, is used. It is around 100 to 300 meters per minute for the short air quenching system. And productivity is optimized by, because of low spinning speed, low production may be there, but to optimize, to increase that, large number of spinnet holes may be in the spinning line, and high tenacity filaments can be produced for particular use. This more number of drawing and heat setting processes are applied here. And this method is even profitable because, yes, low spinning speed is still profitable and used in market versatilely, because of the flexibility in regards of its small color master batches you can produce. Other important spinning method is the long air quenching method. Yes, 3 to 10 meter long length of the cooling duct. High spinning speed is you can kept in this one, and high grade polymer means, yes, for the spinning prerequisite you can say here the high grade polymers. That means the low polydisperse value and is preferable, and high molecular weight is preferable. Partially oriented yarns, means POY type of yarns are produced in this. Now another process, the spin draw process, it is integrated process. You can say the spinning and drawing both are carried out simultaneously. Spinning speed is kept 300 to 700 meters per minute, and the ultimate winding speed is kept much higher, that is 3000 to 3500, means 7 to 10 times stretching can be imparted during this process. And because of its flexibility of the process with respect to the use of the or selection of the raw material, that is the average molecular weight and the polydisperse value, is a wide range you can use in the spin draw process. Normally used for this particular process, used for the high tenacity coarser filament productions, that is used for the industrial production. And also you can produce the fine yarns with texturing can also be produced here. Now next one is the spin draw texturing. Yes, these three processes are integrated in one process, that is used for the BCF, bulked continuous filament yarns, and is particularly for carpet industries, coarser yarns comparatively, and used for that for backing cloths here. Now another important method is the water quenching, and that is suitable for the heavy denier yarns and more than 100 denier, yes, 100 or more than 100 denier filament can be produced, and you can say these are the monofilaments, and 2 to 4 holes in the NS spin rate you can see. And just immediately after that, slow spinning speed is capped, extruded filament is in a liquid stream comes out and enters in a water quenching tank. And then there any drawing is needed, you can later on after cooling the drawing can be needed, can be imparted. Now the next is the another yarn, that is a tape yarn. Yes, for the woven socks you can use the tape yarns for packing also, packing materials, or for another industrial application here. Now PP is extruded in the form of film. Yes, profiled slit film spin rates are used for that, and uniaxial drawing, and also sometimes using the vibrating knives cut these slit film after drawing into the tape yarns. Now on the basis of their functional properties, polypropylene advantages and shortcoming we can list here. You can see that because of its lowest density fiber, it is lightest one amongst the all synthetic fibers, and it is even lighter than the polyethylene and lighter than the water. You can say it's just showing density is 0.91 gram per cc, and does not absorb the moisture quick, so you can use a quick drying property. Yes, and also because of hydrophobicity, or you can say the 0% moisture, again the weight and dry in both condition, wet condition or dry condition, the properties of the fibers remain same or identical before or and after wetting. And again the one of the more advantageous properties, no color of fade occurs. The dyeing is carried out by master color batches by pigmentation approach. So no color fade, no color bleed, you can see here. The excellent chemical resistant, and you can see here the not reactive towards the acids or chemicals. Very low reactivity shows by the polypropylene, and easy processing and higher production rates results in profitable. So one of the manufacturer wants to always go for the polypropylene fiber production, and low thermal conductivity may be used, and means because of that low thermal conductivity one can use for the thermal wears. And but the some limitations also there, it's low melting temperature and high, so limits, one of the biggest limitation of this fiber, can't be dyed after filament formation, means only master color batches pigmentation is there, coloring process is there, and so it limits the use or applications of in the fashion and aesthetic apparel garments, and also low stability against the UV light and heat application, and low resistance than the PET and nylon. Low resilient, not resistant, low resilient means its bulk properties as compared to polyester nylon is slightly lower, and because of low TG, sometimes at even at room temperature undergoes through a normal creep behavior, and again highly flammable nature of this fiber. Yes, applications. The polypropylene established this particular useful for the industries as well as household fabrics, and this fiber is having a limited exposure in the field of apparel garments because of its hydrophobicity nature or lack of dyeability and waxy feel, but fine deniers and texturing making the path in the apparel sector in future. And yes, some of the major application areas, this is the carpet industries as a backing cloth majorly, and also used in the as a pile component. Industrial applications you can use it as ropes and cables and woven socks. Yes, geotextile application, technical textiles here. The geosynthetic material, it is also because of degradation, generally in absence of light and inert chemical good chemical resistance, it can be a very good geosynthetic material. Yes, polygrass by the use of the antioxidants and anti-UV scavengers or absorbers. The by adding this, it's a very good polygrass material. Medical and surgical implants or disposals, not implants. Sorry, here the only for disposal purpose. Tarpaulins, upholstery applications, non-woven. A wide variety of non-woven materials or disposal materials are may be formed, and filter fabrics can be used for the wet filtration in the field of chemical and pharma industries, and also the sports wears, undergarments, swimsuit are the major applications. Thanks.